Problem 8.26. Find a function f that can be expanded in power series of x and such that it satisfies this equation. F prime is equal to f plus x with the condition f series equal to 2. Okay, so the condition that f can be expanded in power series, it means that f can be written like this. From n equals 0 to infinity of a sub n x to the n. That's the idea, right? And we are given already that, so this is, let me see. This is a0 plus a1x plus a2x squared plus a3x cubed, and so on and so forth, right? Now we are given, because f at 0 is 2, we're given already the coefficient at a0, which is 2, right? Now what are the other coefficients? Well, we know that f prime is the derivative of this function, which is the derivative of this, is going to be from n equals 0 to infinity n times a to the n x to the n minus 1. Okay, so in other words, we can write it like this. Let's say at 0 this is 0, right? So typically we can write this like this, 1, right? And then this is, let's say, wait a minute, at 0 this is 0, so we have at 1 this is a1 plus a2x plus a3x squared plus so okay. Now f prime plus x, okay, is equal to, sorry, f prime is equal to f plus x, right? So we have a1 plus a2x plus a3x squared plus a4x cubed plus a5x4 plus blah 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 is equal to, and then we have a0 plus, and then x plus a1 plus 1 x plus a2x squared plus a3x cubed, and so forth. Okay, these two are polynomial expressions. If they have to be true for every x, that means that the coefficient have to be true always. Sorry, it have to be the same. So a1 has to be equal to a0, which is 2. Now a2 has to be equal to a1 plus 1, which is 3. Oh yes, sorry, so this is n, so this was 2, wait a minute, sorry about this. This was 2a2x plus 3a3x squared plus 4a3 a4x cubed plus and so on. Okay, so that's this, we have a 2, a 3, 4, a 5. Okay, so then we have 2a2, it has to be equal to 3, so that means that a2 is 3 halves. Then we have 3a3 is equal to a2, which is 3 halves, which implies that a3 has to be 1 half. Then we have 4a4 has to be equal to a3, which is equal to 1 half, so this is equal to 1/8. But we can maybe rewrite this in different terms, because this will make easier to get a trend from this. This is 3 halves, right? And then this is 3 divided by 2 times 3, 3 times 2, which is 3 factorial, right? So this is 3 divided by 3 factorial. Now here we have that a3, this is 3 divided by 3 factorial divided by 4, so a4 is going to be equal to 3 divided by 4 factorial, and 5a5 is going to be 3 divided by 4 factorial. So in other words, a5 is going to be 3 divided by 5 factorial, and in general you can get the idea that this is going to be 3 divided by n factorial, right? So then we can go back here and write this sum originally. So this is 2 plus 2x, and then everything else is 3 times the sum from n equals 2, starting at 2, right? From infinity, this is x to the n divided by n factorial, actually. But this is e to the x, right? It's starting at 2, so e to the x minus the 2 first term minus x minus 1. So this is f is 2 plus 2x plus 3 times e to the x minus 1. So if you operate with this, you have 3e to the x minus 3x plus 2 plus x is minus x, minus 3 plus 2 is minus 1. Okay, so this is the function that we are looking for.